This video covers section Trig I. In this video we're looking at angles of elevation and depression. Firstly, let's look at an angle of elevation. The angle of elevation of an object from an observer is the angle between the horizontal and the line of sight up to the object. So if you look at this picture, our person is essentially in the boat and they're looking up at the lighthouse. The angle of elevation is between the horizontal and that line of sight. In contrast, an angle of depression of an object from an observer is the angle between the horizontal and the line of sight down to the object. So in this case, our person's up in the lighthouse looking down at the boat. So the angle is between the horizontal and that line of sight. So things that you should note here is that the angle is always between the horizontal and the line of sight. No matter if it's for elevation or depression, it's always between the horizontal and the line of sight. Depression, you're looking down, kind of makes sense. Elevation, you're looking up. So let's look at an example. A person observes that the angle of depression from the top of a building to a car on the road is 17.5 degrees. Find the height of the building if the car is 150 meters from the base of the building. Okay, so if this is my building, no artist, okay, the person observes that the angle of depression from the top of a building, so the person is essentially on top of the building here, down to the road is 17.5 degrees. So here's my horizontal. So between the horizontal and my line of sight is 17.5 degrees. And on the road I have a car. Looks more like a pram, but anyway. Find the height of the building if the car is 150 meters from the base. So this is my X here. Now note there's a few assumptions. Number one, we're assuming the ground's horizontal. Number two, we're taking our line of sight as being from the top of the building down, and we're taking the car as being on the ground as well. So there are a few assumptions here. Now, if this is my 17.5 here, using alternate angles, this is 17.5 degrees here. Okay, here's my right angle. There's another assumption. We're assuming the building makes a right angle to the ground. We're not talking about the Leaning Tower of Pisa. So here's my opposite. Here's my hypotenuse, and this is my adjacent. So the information we're given is we have adjacent and we want opposite, so therefore O and A is tan. So tan theta equals opposite over adjacent. So tan of 17.5 is going to be the opposite, which is X, over my adjacent, which is 150. Whoops. So X equals 150 times tan of 17.5 degrees, which is approximately 47.29 meters. So therefore, the building is approximately 47.29 meters tall. Okay, let's look at another one. Sam's eye level is 150 meters above the floor. So I'm going to draw the floor, and then I'm going to draw Sam. This here is 55 centimeters. So note, I'm trying to interpret the question as I go. When he stands against a wall, he can see a spider on the opposite wall. Okay, so there's obviously a wall here, and here's my opposite wall. And the spider should have 8 legs. Okay, so he's looking up at the spider. And the angle of elevation again is with the horizontal is 10 degrees. And we're going to assume that this is a right angle here. If the walls are 4 meters apart, now this is why it says Sam is standing against a wall, because when I say this is 4 meters, then I can say this is 4 meters here. How high on the wall is the spider? So I actually want all of this here, but I'm going to have to work out this bit first. Okay, so let's label. We have opposite, we have hypotenuse, and we have adjacent. So adjacent and opposite, so it's tan again. You find that a lot with application problems. So tan theta is opposite over adjacent. Tan 10 equals y over 4. So y equals 4 times tan of 10, which is approximately 0.7053, and that is in meters. Okay, you notice the textbook actually changed the 4 meters into centimeters first, whereas I've done this the opposite way around, and I can convert this to approximately 70.53 centimeters. Okay, reason why I want centimeters is because the height of Sam's eye is in centimeters. Alternatively, I could change it to 1.55 meters. Either way. Okay, so the wall is going to be 70.53 plus 155, which is approximately 225.53 centimeters, or 2.26 meters. Okay, so finish with a therefore statement. So I have the spider is approximately 225.53 centimeters, or 2.26 meters up the wall. Okay, another example. A ship is viewed from the top of a 28 metre tall oil rig that is 18 metres away. What is the angle of depression from the top of the oil rig to the boat? Now you notice when I'm drawing these that they're sometimes in the opposite orientation to what's in the book, so it gives you an idea that it doesn't really matter. So again, no artist, but you get the idea. So a ship is viewed from the top of a 28 metre oil rig. So from here I'm looking down at the boat that is 18 metres away, and the angle of depression I don't know, so I don't know that angle there. Now I have a 28 metre tall oil rig, which is that there, and I'm going to assume it makes a right angle with the water. Okay, so the assumptions are the oil rig is at right angles with the water, the boat and the oil rig are at the same elevation, and probably that our water is flat, okay, and that we're measuring from the very top to the very bottom of the water. So, alternate angles here with my Z, so this is my theta, so I've got opposite, hypotenuse, adjacent, so again we're looking at tan. So we have tan theta equals opposite over adjacent. Tan theta is 28 over 18. So theta is going to be tan to the minus 1 of 28 over 18, which is approximately 57.3 degrees. Finish with a therefore statement. So you have the angle of depression from the top of the oil rig to the boat is approximately 57.3 degrees. Okay, last example. A person on a boat sees a plane at an angle of elevation of 14 degrees. After the plane has travelled 20 kilometres closer to the boat at the same altitude, the angle of elevation is now 22 degrees. At what altitude is a plane flying? Okay, so I have a plane and I have a boat, and the plane is flying towards the boat. Okay, now a person on the boat sees a plane at an angle of elevation of 14 degrees. After the plane has travelled 20 kilometres closer, so we'll say that, the angle of elevation is now 22 degrees. Okay, and what altitude is a plane flying? So that's X there. Okay, so things that we need to work out, I've kind of got two right angled triangles. If I bring a dotted line down to here, I can have this being my X, and this here is going to be my X plus 20. So let's draw a diagram, separate those two right angled triangles out. With this triangle here, I've got 14 degrees, and that's my X, and then my next triangle, where this is X. Okay, this angle is 22 degrees. Okay, and again this is, I've got too many x's, don't I? Let's make our height being h, our altitude. Okay, so from there we'll call this position 1 and this position 2. So position 1, what I need to find is h. Okay, so if I label this triangle, I have opposite, hypotenuse and adjacent. So again I'm looking at tan. So tan theta equals opposite over adjacent. Tan 14 equals h over x plus 20. So multiplying both sides by this x plus 20, I end up with h equals x plus 20 tan of 14. Position 2, again tan theta equals opposite over adjacent, so tan 22 is going to be my height over x, so my x is going to be h over tan of 22. Equation 1, equation 2, sub equation 2 into 1, and I get h equals h over tan of 22 plus 20 times by tan of 14. Expand that out, I get h tan 14 over tan 22 plus 20 tan of 14. Get the h's on one side, h minus h tan of 14 over tan 22 equals 20 tan of 14. Factorise, h will outside of 1 minus tan of 14 over tan 22 equals 20 tan 14. I've run out of room, so I'm going to go onto a new page and I'm going to write that line out again so you can see where I'm at. Okay, so from there I need to get that h on its own. So I'm going to divide everything by this, so I end up with h equals 20 tan 14 all over 1 minus tan of 14 over tan 22. Plug that on your calculator and you get 13.02 kilometres approximately. Finish with a therefore. Therefore, the plane is flying at an altitude of approximately 13 kilometres. So what now? We'll complete the exercise Trig I from the textbook, which is all on angles of elevation and depression.